Hello there, good evening, good afternoon, good night, wherever you are. We are taking a look at this twisted pathway today. It is a inspiration by Les Jardins Mallet-Stevens et la Villa Cavois. Terrible butchering of the name, obviously. However, this will be a representation of this kind of pathway that they have here and how it basically twists around this straight pathway, but you have this box that changes its shape and form. And we did this by using Grasshopper and Rhino, and we can obviously change the overall size. We can lower the size in general, like the height of it. We create the distance and how far apart they should be. And then we can also just increase the amount of it, so it just generates itself almost. And then we also can make it a little more thick, let's say, and then we can have this thicker kind of outline to it. So I will walk through this this tutorial. The next tutorial, then we also will take a look at the construction points in between those. As you see here, you have those construction points in between that are always at the same location, and they have this way of how they're connected. But this will be something that we will not be discussing today. So just to go to the general idea, we will create this box. Let me just draw this down in a new file. So we're just gonna take a new file here. So we will just have a basic rectangle, and this rectangle then will be duplicated like one after the other, and it will be, can I actually duplicate this here? Oh yeah, so it will be duplicated again, and then we will basically, out of each of those things, we will have a plane there and like a definition, and we will just rotate it around each of those things. So this one we wrote it like this, the next one will be a bit more, and then once we have this, I would now go to like a section view. Okay, we have the section and we have each of those things. However, they will be sometimes a bit longer, a little bit like small, they go like over and under above it. And what we want to do is basically we want to make sure that those correct pieces gets like used or collected, so only the upper ones will be the ones that will be shown here. Okay, so we will just start very basic, very simple. We are going to, well, first of all we play the logo and then we get right started. Beautiful. Okay, so we keep this going. So we are just gonna create a rectangle for now, and this rectangle normally is at like the base plane as you see here, but we want to be it more like a upright version of it. So we're just gonna create a XZ plane, for example. So the rectangle will be based upon that, and we give the rectangle also a certain dimension. We just like a number slider that we're gonna put in here, like this, now 2 to maybe 20, and this will be the rectangle will be created. Oh, it has to be put obviously in the plane radius like this, so it works correctly. And we also want this rectangle to be basically from here in the middle, so it will be turning around this middle base point. So we are going to create just a matrix basically under, wait, let me create a boundary, and under constructing domain, and we will basically take the negative of the value and the positive, and we take it as a domain start and finish point. So it will basically be from negative here to positive here, and from positive negative here to positive here. That will be is basically the definition of this rectangle that we just created, from 15 to minus 15. Okay, now we also we have that, and we want to now move this plane from one place to the next one. So we're going to do this by just moving, just move them basically, and make a series that will basically go from one to the next one in a certain step. And the count will be the amount of frames that we want to have. So frame count, and the step count will be the distance of it. So we're gonna make this by distance frame, and we're just gonna put those in here. And because we have a XZ plane, we have to move it into the Y direction. So we're going to do this by just using the Y, put it in the motion, and then use the rectangle that we put in the beginning here to move this here. And as you see, the distance might be a little bit too much, so we just put it a little bit closer, and this would be working fine for now. Furthermore, we want to create a rotation that we want to have here, basically those red things, that it each rotates around a certain part. So we are going to from one to the next one. So we're gonna create a series actually again, or we can also just copy this one, because we have to take the same amount of count, because it will be the same amount of frames that needs to be rotated, but we need to have a different angle, basically angle frames of this here, and we will take this into the step counter, and we are going to use the rotate command that takes the geometry that we want to rotate with. So this one, it takes the plane that will be actually we actually gonna duplicate this plane from the original one, like here. So this will be our base plane, and the angle will be the angle that we move from the series, and we might want to actually right click it and use degrees. So otherwise it will be, well, it will still work, but degrees are just way more logical in my sense, I guess, and they can be used like that. Oh, by the way, I will also put a link in the description down below of a GitHub thing where you can just click on and just download the file, so you can follow along. But if something messed up and you don't know what the fuck it was going to happen or what happened, and you don't have the time to debug it, you can just like download from there. Anyway, but for understanding it, I think it's pretty important to just like chug along. So now we have our defined like rotated angles already, so this looks already pretty nice and pretty good. However, the problem right now is that it's still like a whole rectangle. So what we want to do is basically define the points where those things get have to be like separated. So one way to do is actually we go under the vector, or not, under intersection, and then we're going to use on a physical and surface curve. So this is one way to do it. We can also, I think we can use the line and plane. As far as I know, I'm not that sure actually. Anyway, this should be actually working. So we're gonna create a surface that will cover the ground, and then those curves will basically be splitting the surface, and then we get the points that we want to need here. So this surface will need to be at least as big as the amount of the count at the steps, so basically the distance between the frames and the frame amount. So we're just going to multiply that, and by that we have basically the total amount of how big it needs to be. And then also, just for good measures, I will also create a boundary. I cannot type, under math domain construct domain, and we're just gonna create this in the X and the Y direction as well. This way we also have basically like it's like a ground that will be like this, as you see here, and it covers all the place, as well as if you want to increase or decrease this amount. So it always needs to be a little bit bigger, because we want to use it as this intersection point. So we're gonna use a boundary surface that will make this like as a physical object, and we're going to use this as the surface, and here the curves. And now, as you see, we have those really nice points exactly at the edges between those. And also, again, if you change those things will change along with it. However, now we have the points defined of where those points need to be separating those frames. However, we need to still, the curves are still like one thing basically, they don't get split. So we have to use the command shatter, which basically makes small segments out of the curve. So we're gonna use it, we're gonna go from the curves here, put it in here, and take the parameters of those ones. And as you see the outcome, if you're gonna take a panel and put it here, you have every time two polyline curves. So instead of having just like those rectangles, as you see here, we actually have two polyline curves because they got split at those points. And we are going just to, yeah, now we have those split curves, and we want to basically select the top one, for example. So we want to, and you will see there will be a little error, but we want to select the top curve every time and not the bottom one, because we have to distinguish which side we want to take, right? We want to take the top one. So we're gonna and you see what will be happening here. So if you're just gonna take this as a list, you will see that if you're just gonna hide those things, I still want to take the bottom plane here. Okay, and then we need to put this in the geometry here. Well, first of all, this doesn't seem to work as intended at all, because we need to actually graph the tree, because as you see here, each of those parameters, it creates a new kind of tree group. So you see you have those lines in between, and it says like 0, 0, 0, and then there are two values here, 0, 0, 1, and it takes two values here again. So we basically need to do the same thing with the curve. And if you go here, for example, you see it's just 0, 0, and then there are all those areas in here. So we basically need to graft it, and this still doesn't look at all the way of how we want it to be. Also, if we increase the frame code, it just like, then it starts again and then it goes under again. It's kind of weird. So it's not really like the exact solution that we're looking for. However, it goes in the right direction. We can combat this like either, well, I think there's kind of like a mathematical function in here, and we need to define at what degree of turning it would need it to be switching to the other index. However, that will take a lot of time, and there are other ways of making this a little bit easier. So there is this command, and I have to see exactly where it is at the moment. I think it's called brep. Yeah, it's under surface analysis, and then it would be shape in brep, this one. And what it basically does, it takes the brep, like the like a box, and then a geometry that is inside or outside, and then it gives us a result if it's inside or outside, and then it gives us the perfect number to it, so that we need to know which one of those indexes we need to use in this case. So this is basically, it sounds complicated, but it's actually not. It's gonna be easy. So we're just gonna create first this box that will be needed in this case, and we're just gonna create a box rectangle, and the rectangle will be the base plane of the big rectangle that we created here in the beginning, and we give it just the height because we give it the height of a multiplication of like by 2, let's say. I think 2 would be enough, of the base length or size of our thing here. And you see it basically covers the whole thing in a way. So this would be working fine. And we're gonna use this as the base brep from here to look for, and we are going to use the shape here. Now we would have, from each of the rectangles, you would have the shapes in here. However, we have the problem, as far as I know, that at the moment it will give us the intersecting outside or inside relation. Oh no, we actually need to take it from here, I'm sorry. And now it would give us if it's intersecting or not, or both. Or the problem with that is, though, however, that we want to be that it's gonna be actually be in there, or like if it's just intersecting or not intersecting at all. So and at the moment this box is actually exactly intersecting the bottom one as well as the top one, so it just gives us ones, which one, as you see here, it is just the intersecting value. So we are going to just move this box a little bit like upwards, just like a tiny fraction into the z direction. Yeah, just this could be like a very small value. It's a little bit like kind of a ghetto style making it, but I'm fine with this for now because it's very fastly, it can compute it very, very fast. And as you see now, it gives us certain values like here's 1, 2, 1, 2, 1, 2. So like the 1 is like the top one, or 2 is the bottom one. And it should be switching around later. Here it's 2, 1, 2, 1 because it turned around in a way. And the way it's actually, just to explain why it did that at all, is because you have those curves that exist in the geometry here, and they always start at the same point. So this curve here starts at this point starts here and there and there and there, and kind of rotates around. And the problem with that is that the parameters where it should be kind of cutting it off then suddenly switches to the top side, and it doesn't really know from which side would be the top and which would be the bottom. So this is what we're basically taking back in this example. So now we have this defined already, and we're gonna need to put it back into the index. However, this index just goes from list to, so the list has two numbers in it, so it has the integer of 0 or 1 where you can define it, but this goes from 2 to 1, so we actually will need to subtract 1 from that, so it will create the correct number. And I think also using list items actually not the best way to do it, but actually would be dispatch. So we're gonna dispatch the items from here with this pattern of the subtraction that we have from the relation in of the bref. Anyhow, let's just hide those things here. And now there is obviously nothing out here. Let's see if we're gonna, I don't know why. Yeah, we need to not use the relation as the list, but we need to use the segments. And now we have to hide the dispatch button. And yes, you see this one is the one from the bottom, and this one will be the one from the top. So this works exactly as intended, so that's pretty nice to see. And obviously if we change the parameters around, it will actually change accordingly to that. Okay, we're already in like 18 minutes. However, we're going to make this all three-dimensional and give this little thickness that we have here. We're gonna take a look at this in the next tutorial, and we also are, if you have the time, I think we will, we are going to take a look at the combination of how to connect one part to the other one, and how we can basically make this a little more richer in a way. So thank you very much for watching, and see you in the next one, I guess in part 2 of this small series.